Welcome to the Microsoft Open Source NNI video series. In our last video, we introduced how to prune your model with NNI. In this video, we will show you step by step on how to quantize your model with NNI. This is the model compression pipeline in NNI. You can easily get a compressed model by applying pruning or quantization, or both, on your pre-trained model. Let's look into the details of quantization. Quantization refers to compressing models by reducing the number of bits required to represent weights or activations, which can effectively lower the computation cost and the inference time. In deep neural networks, the main numerical format for model weights is 32-bit float. Many research works have demonstrated that, by applying quantization technique, weights and activations can be represented using only 8-bit integers without significant loss in accuracy. The quantization process in NNI consists of 3 stages: quantization simulation, fine-tuning, and speedup. The quantizers use raw precision emulating low-precision operations to simulate the quantization effects by scaling techniques. A fine-tuning stage is usually required to recover the precision lost due to quantization simulation. The speedup stage physically reduces the high-precision operations to low-precision operations by converting the model to a TensorRT engine. So, this is the complete quantization pipeline in NNI. Now let's do a quick start to show you step by step how to quantize your model with NNI. The first step is to prepare your pre-trained model. If you are familiar with defining and training a model in PyTorch, you can skip this step. This part defines the optimizer and pre-train the model on MNIST dataset. After you prepare your model, you can start quantizing it right now. You need initialize a config list first. You can refer to compression config specification part in our official document for more details about how to write a config list. Here I give you a simple but typical example. The op types defines the quantized module types. The op name specifies the quantized module name. The quant types indicates the quantization targets of the modules. Currently, NNI supports 3 kinds of quantization types: weight, input, and output. Note that input and weight must be configured and quantized simultaneously. The quant bits defines the target quantization bit length. So, this config list tells that the modules of type conva2d will quantize input and weight to 8-bit. The modules of type relu will quantize output to 8-bit. The modules named FC1 and FC2 will quantize input and weight to 8-bit. After setting up the config list, you can initialize a quantizer. NNI implements a lot of quantizers, such as naive quantizer, QAT quantizer, BNN quantizer, and so on. Here we take QAT quantizer for example. Then, call the compress function and print the model. You can see the target layers have been wrapped by quantization module. QAT is a training-aware quantizer. It will update scale and 0 point during training stage. So here we retrain the quantizer for 3 epochs. Note that compress function only simulates the quantization effects, not really speed up the model. Now we export calibration config. You can see the bit length is now 8-bit as specified in our config list. The final step is to build TensorRT engine to make a real speedup. For more information about speedup, refer to Speedup Model with Calibration Config chapter in our official document. Thank you for watching our tutorial videos. Feel free to comment below if you have any questions. You are also encouraged to join our user group for further discussion.